All right. Once again, good morning, everybody. Today we'll see I will give the introduction of the basic electrical engineering. In case of basic electrical engineering, we are going to study about the basics of electrical engineering and why studying basic electrical engineering is important for all the branches. For definitely for electrical branch students, going forward, you are going to learn the advanced concepts. For that you need a basic knowledge about the electrical engineering, so that way whatever you are going to study, you are going to explore more on those particular topics. And for E and C, definitely there are many concepts regarding the DC circuit analysis, resistors, inductors, capacitors. Okay, and all those information will be helpful when you go to the your respective branch. And for civil engineering, one of the important thing, whenever the building or the house is being constructed, there is wiring involved in it, electrical wiring. And civil As a civil engineer, you should have a knowledge about what type of wiring will be used and how it will make a difference in his particular design. He should be aware. Having the basic electrical knowledge will help him in accommodating that very easily. And for mechanical engineers, they build many kinds of machineries, tools, okay, equipments, which will involve the many electrical things like a motors. If we are talking about any kind of a motion that is involved in the machine, definitely we will need a motor. What kind of a motor has to be used, and what is the capacity, AC motor, DC motor. In order to make all those decisions, mechanical engineering students should have the basic knowledge about the electrical engineering. And similarly for other computer science and engineering, basic knowledge about the system, the computers, the laptops, the modems. They have a power requirement. What kind of a power required? Okay, what kind of a supply should be given? That information. And in general, not only engineers, everybody should be aware of certain aspects of electrical knowledge. For example, like everybody in your household, you have the meter, right? Every house has a electrical connection. How that electrical connection comes, what is a meter board, what is the energy meter. So all those information should be known to everybody, which will help in day-to-day activities. One second, hold. Okay, so electrical supply, what kind of a supply we get? AC, single phase, three phase, what is the meaning of that? And in our house, there are certain safety devices are there. For example, we have the fuse will be there, and MCBs will be there. You should have the knowledge how the wiring is done inside the house. What is the safety precautions should take in case of any kind of emergency which is related to electrical hazard. So all that information, as a common man, we should be having that particular understanding. In that respect, this electrical engineering knowledge is very, very important. So this knowledge of electrical engineering you can carry forward with your respective branches. And no single branch it is complete in itself. The meaning of that is every branch is dependent on other branch, right? It is a if it is like a, if we talk about the robotics, right? Robotics is a combination of knowledge of mechanical engineering, electrical engineering, E&C engineering, and CSE engineering, right? If you want to make a robot for getting the motions, the right kind of motions, you need a mechanical devices. Uh, and to make that particular thing to work, you need electronic devices. And if there is any kind of a interfaces you want to build, you will have to have the some kind of a software components to it. And the whole these things, you will involve the motors, the electrical power, how much power is required, DC, AC, all those questions. So this is a culmination of all the engineering. Similarly, I told about constructing a building. Now, construction of a building, definitely it is a civil engineer's job, electrical engineer's job, and many buildings now are coming with sophisticated controls for the AC, for the lights, so IoT devices. So that is related to electronic. So every branch, if you consider, they are interdependent. That is how you should be having the knowledge about the all these basic knowledge. And once you are working in particular area for, let us say, robotics, you can deal in detail into whatever the knowledge that is required. Okay, so that is the importance of a basic electrical engineering. And from the exam perspective, if you want to complete your degree, you have to clear every branch, every subject which is been offered to you. So that is how, from exam perspective, passing is very important. And from knowledge perspective, to become a very successful engineer in whatever the discipline you are, having this particular basic knowledge of electrical engineering is very essential. Okay, so you take this from the knowledge perspective. So electrical engineering, now you have joined the engineering is mostly it is like a building, right? So engineering is nothing but a build. So you maybe in the first year, the kind of a subjects will give as a foundation for the engineering. And from third sem onwards, you will gain a knowledge which can be used to build something, right? You can, if it is a computer science and engineering students, excuse me, you can build softwares. Okay, if it is a mechanical engineer, you can build some parts. If you are civil engineer, you can build in that particular area. So that is how, as you keep on progressing into second year, third year, fourth year, you will be acquiring lot of knowledge which you can use, and you can build something. Clear? So basic electrical engineering, from the exam perspective, uh, the question paper will have 10 questions, and this particular subject is divided into 5 modules. Okay. Every subject is divided into 5 modules, and your scheme is 2018 scheme. And in the exam, as I told you, there will be a total of 10 questions, 2 questions from each module. Okay, so module 1 to module 5 into 2, that is total 10 questions. And in each model you have a choice. Okay, you have to solve one question from each module. So total you have to answer 5 full questions, selecting each from a single module. And the questions will be designed in such a way, it will be covering the whole module. So it is not like question 1 will cover the half of the module and question 2 will cover the half. No, the questions are prepared in such a way that each question will cover the entire module. So saying, being said that the importance of understanding the complete module is very important to solve any questions. So it is not like if you do half module, you will be able to solve one question. It is not like that. You have to study the complete module. Okay, that is the external exam. And internal CIE marks, you can see this is the internal marks and this is the external marks. CIE is continuous internal evaluation, that is for the 40 marks. These 40 marks are divided again into internal assessment test that you are going to write 3 IA test you are going to write, and 30 marks is given for that, and average of those 3 tests will be taken for the 30 marks, and rest 10 marks I will be giving assignment for that. So 2 to 3 assignments. When you do the assignment, when you submit, based on your submission, that 10 marks will be allotted. So 30 plus 10, that is the 40 marks. So external exam will be conducted for 100 marks, and it will be scaled down to 60. So this is how this external marks plus internal marks will be your total marks out of the 100 marks. And every subject has a code. Okay, the code for basic electrical engineering is 18ELE13. This is for the first sem, that is you are studying the basic electrical engineering in the first semester. The chemistry cycle people will study it in the second semester. Then the code would be ELE23, and the total credit for this particular course is 3 credits are there. Is the course objectives. This is the syllabus copy that I'm going to share. I'm going to put this particular syllabus copy in the in the Google Classroom. You can refer. Please refer to the syllabus so that you will know how the coverage is, how I'm covering the subject, and also it will give the reference books. So we'll talk about that reference books once we go through this syllabus copy. The course objective: to explain Ohm's law and Kirchhoff's laws used for the analysis of DC circuits. So we are going to look into the Ohm's law as well as the Kirchhoff's law, and it is already many of you have already covered it in the PUC level, and you are well aware. In spite of that, we are going to look into these 2 laws in detail. We are going to solve the problems based on the Ohm's law as well as the Kirchhoff's law. So this is the analysis used for analysis of a DC circuits. Then to explain fundamentals of the AC circuits. AC is alternating current, DC is direct current. As you might be knowing, direct current will have a definite direction. Current will flow from the positive plate to the negative plate, and DC current will have always a proper fixed direction. It depends on what kind of a circuit you have. The direction might change, but it will you will be able to definitely tell what is the direction. In case of a alternating current, it constantly changes its direction as well as the magnitude. The kind of alternating current that we use is the sinusoidal, right? The kind of supply you get to your house is a single phase alternating AC supply. So all the power is generated as 3-phase. Okay, the power generation, it happens as a 3-phase. We'll understand. If you are not understanding 3-phase, don't worry, we are going to cover it in the one of the modules. The power is generated as 3-phase, power is transmitted as 3-phase, power is distributed as 3-phase, and whenever you are getting the supply to the domestic supply, it will be given as a single phase supply. So how the supply is taken into your house, what are the different ways, how the wiring is done, we are going to cover that. So that is the alternating current. So if there is an alternating current, how those circuits will behave when it has a different kinds of loads, and what are the different loads we are going to study on the AC circuits. We are going to connect a AC supply to a resistor. R stands for the resistor, and we are going to do the analysis. And then inductor, having a inductance of L, we will connect it to the AC and AC supply, and we do the perform the analysis. And similarly, we connect the AC supply to the capacitor with capacitance C, and we are going to do the analysis. And also we are going to use the combinations in AC circuit. What is the combination? There are going to be 3 combinations we are going to use. One is RL, that is resistor and inductor in series. Then resistor and capacitor RC in series, and the last would be resistor, inductor and capacitor in series connected to an AC circuit. So that is the another objective. To discuss three-phase balance circuits, we will see what is a three-phase balance circuit. To explain principle of operation, construction, performance of electrical machines. So, the electrical machines that we are going to see is the single-phase transformer. For each of these machines, what we will study is what is the principle of operation, how does that particular machine operates, and we will understand the very high level construction, how that particular machine is constructed, then how and the performance of those electrical machines. So which are the machines we are going to cover is a single phase transformer. I'm sure everybody must have seen the transformer. So transformers comes in various sizes. You have very small transformers in the electronic devices, and you can see huge transformers if you have visited any receiving station or the distribution station, or in your street there will be a sizable transformer. So we will see how what is the principle of operation, how construction is done, and how the performance. We will see about the performance, and we will see about the DC machines. In case of a DC machines, we are going to study DC generator. So what is a DC generator? Which generates the DC supply. We'll see the operations, construction, and performance. And DC motor. What is a generator? A generator is the machine. DC generator is the machine which converts mechanical energy into a DC electric supply, and DC motor is the machine which takes the DC supply as the input, and it converts it to a mechanical energy. So mechanical energy in terms of a rotation. And we will see about the AC generator, which is also called as a synchronous generator. So AC generator, synchronous generator, we will study what is its operation. And this generator, synchronous generator, it converts mechanical energy into AC supply. And three-phase induction motor is nothing but it's a AC motor which works on the principle of induction. It takes the three-phase AC supply, and it converts it into a mechanical energy, that is a rotation. To introduce the concepts of electrical wiring, circuit protecting devices, and earthing. So we are going to understand about what is a electrical wiring, what are the different ways the wiring can be done, and what are the protective devices, right? We know when we are dealing with the electricity, we have to be very careful, and we have to use all the precautions, and we should use the protecting devices. We'll see what are the different protecting devices. Some of the protecting devices which you have already seen in your home is a fuse, as I said, fuse, and the MCB. So what happens if there is any fault inside your house? Uh, if most of the time MCB will trip, right? MCB will trip, means trip in the sense it will disconnect. The minute you disconnect the circuit, current will stop. Whatever the emergency short circuit will it will stop supplying the current. So that is how equipment or the human resources, if they are involved, they will be protected using the protecting devices. Another one is the fuse. If the fuse works on a principle, it allows a certain amount of a safe current, that is rated current. If it goes beyond that, there will be a fusing element, it will melt. So that is how it will disconnect the circuit and it will protect. And earthing is a most important thing. Every house, every building, every structure will have the earthing. Earthing will help us in taking any fault current. If there is any fault current in the body of the any equipment, you must have experienced sometimes, like you touch the fridge or your washing machine or any other electrical devices, and maybe there is a coating has gone. Then you will experience little small shocks. That is the reason, because if earthing is not proper, that is how it will flow through the human body. If earthing is proper, that kind of a fault current will directly go to the earth, and it will protect the equipment, and it will protect the human beings. That is the course objective. In the first module, we'll go through all the modules. You will come to know what you are going to study under basic electrical engineering. In module 1, this module 1 is very simple. This at least half of this is already you have been exposed. This particular module you should target. You should definitely attempt the question with very without any issues. You'll be able to score maximum marks in this particular module 1. So module 1, it consists of DC circuits and the AC fundamentals. In DC circuits, we are going to study about the Ohm's law, Kirchhoff's law in detail. Then we are going to solve different kinds of circuit problems based on the Ohm's law and the Kirchhoff law. Then we are going to do the analysis of the series. Okay, in case of a DC circuit, the only load is a resistor. That is the only load. You have to remember, if you are talking about the DC circuit, the only load is resistor. In case of a AC, we can have a resistor, we can have an inductor, or we can have a capacitor. So series, so we will have a when resistors are connected in series and across a DC supply, how it will work, what are the different parameters, what are the what is the current that flows, what is the voltage across each of those resistors. We are going to study in that. Then resistors connected in parallel, and third one is resistors connected in series and parallel combination. We are going to do the analysis of those circuits. So these different combinations, series parallel and series parallel, connected to independent voltage sources. Then we will understand the concept of what is power and what is energy. Next, in case of a AC fundamental, how the AC is generated, we will understand generation of a sinusoidal voltage. I told the alternating current that we use. Alternating current are there are many forms. A square waveform is also alternating. If it is a triangular, that is also alternating. Alternating entity, voltage or current, which says like whenever with respect to the time, if the magnitude or direction or both are changing, then we call it as a alternating current. What we use is a sinusoidal. We'll understand the why we take the sinusoidal voltage, what is the advantages it gives over the other kind of waveforms, and why they have zeroed on sinusoidal for the alternating current. Frequency of the generated voltage. So once we have the sinusoidal, it will have the frequency, and we'll understand what is the frequency. So your household has a AC supply, isn't it? What is the frequency? Anybody knows what is the
60 hertz.
50 hertz.
50 hertz?
50
Correct.
hertz.
Very good, very good. See, the frequency for a country, they will keep it as constant. In India, the power generated, irrespective of where the power is generated, which state is it is generating, which generating station it is generating, they have to generate with the 50 hertz. And all the equipments, and what is the voltage?
240 volt.
Okay,
220 volts.
220.
220.
Okay, will come to know exact what is the exact voltage, but 220, 230, 240 is accepted answers. So in India, we produce very close to 240 and 50 hertz. The power supply is always 240 and 50 hertz. And why it is important? All the equipments that are available inside your house that are manufactured in India, they are designed for, if it is like a domestic purpose, it is designed for 240 volt and 50 hertz. So you check with any equipment in your house, uh, uh, behind every equipment there would be a label. Just you can go and check. They will specify voltage, frequency, and they will specify the power. Power would be like 1,000 watt, or 1 kilowatt, or 200 watt. That is the power. We will understand what that power meaning. So voltage you understood, and the frequency we will so your question is why we are having the 50 hertz, isn't it?
Yes, sir.
Okay, so India has chosen, they have done a kind of like analysis in electricity. Most of the countries, they follow 50 hertz. And some countries, to name that country, USA, right, United States of America, they have chosen 60 hertz. So it is just by the way of the research, they have come up with this particular frequency. So in India, it is 50 hertz. I'm not sure about the Europe. USA has 50 hertz. USA and Canada, they use 60 hertz. Sorry, not India uses 240 volt and 50 hertz. US, Canada, they use 110 volt and 60 hertz. And all the equipments that are created in US, they are designed for 110 volt and 60 hertz. If you know of any of your friend or relative who lives in America, if they bring any electrical equipment for you, you have to make sure that you use the converter. Some of the devices, they design it for like 110 to 240, 50 to 60 hertz. If it is designed like that, you can directly use that in India. If it is not, you have to use the converter. You have to make 240 volt, and for frequency we cannot make anything. So 240 volt, and it will work on that particular thing. So the answer to your question is, it is used as a standard. So in India, the standard is 240 volt and 50 hertz. Okay.
Sir, same with the voltage also.
Voltage also, yes, same. It is the standard. So actually, it is 440 volt is the three-phase voltage. 440 divided by root 3. So whatever the number you get, 239 point something, that is the single phase. We will understand those calculation, how those calculate, why I divided it by root 3. We'll understand.
Thank you, sir.
Okay. Any other questions?
No, sir.
Okay. So this is where you will understand that. Okay. Frequency of the generated voltage and definition and numerical values of average value and root mean square value. So when I asked what is the voltage in your house, you said 240, right? But we told it is alternating, right? It is changing. So it will become 0, it will go to maximum, it will come to 0, go to negative maximum, and it is come to 0. Then what is the 240? To give the answer, we will understand what is a average value and what is a root mean square, RMS value. So whatever the value you said 240, that is nothing but the RMS value. We will get more details when we study about this. Then form factor and peak factor, these are based on the average value and the root value. These are just the simple formulas of sinusoidally varying voltage and current. Then phasor representation of the alternating quantities. So one way to represent the alternating quantity is a waveform, right? You can draw the waveform, you can give the time period, what is the maximum value you can give. That is how you can represent the alternating quantity. There is another way which is very easy to represent, that is a phasor representation. We will see how we represent the alternating quantities using the phasor representation. Okay, so 10:30. Okay. Next one is the single phase circuits. In module 2, analysis of a phasor diagram. Then circuits with, I told you, with the R, L, resistor, inductor, capacitor, combination RL, RC, RLC, how these things work in the when we give the AC supply. We are going to understand what is the current, what is the voltage, okay, how to calculate the impedance, all those things. We'll study what is the power consumed. We'll understand here. We'll understand real power, reactive power, apparent power, and the power factor. Then in three phase, advantages of three phase power over the single phase. Generation, how to generate the three phase power, three phase balance circuit, voltage and current relations in star and delta connection. We will study once we do the three phase. Three phase will have the three different phases, and three different phases can be connected in two fashion. One is a star fashion and one is the delta fashion. And how to measure the three phase, measurement of three phase power using two wattmeter. Wattmeter is nothing but that is a meter that is used to measure the power. In module 3, we are going to study about the transformer, single phase transformer. What is the necessity of the transformer, principle of operation, what are the different types of transformers, how transformers are constructed. Then we'll see EMF equation, and this is the performance. What are the different losses that occur in transformer? Then variation of the losses with respect to the load, efficiency, condition for maximum efficiency. Here, just understand we are going to study about the transformer and its performance, operations, its construction. For all the machines, you are going to study the same. In module 3, we are going to study the domestic wiring, what is the meaning of service mains, what is the meter board, distribution board, and brief discussion about the concealed conduit wiring. In some houses, you see the wiring. In some houses, you don't see the wiring is inside the wall. So we'll see different types of wiring, and a two-way and three-way control of a switch. Two-way example is, if you are living in a building, or there is a staircase, there is a one switch at the bottom of the staircase and one switch at the top of the staircase, but it will be controlling the only one light. So that is called a two-way control. Using locations you are controlling. So when you are going up, you will switch on, okay, and when you go to the top, using another switch, you will switch it off. That is a two-way. Then elementary discussion on circuit protective devices. We are going to see protective devices, fuse and MCBs, that is miniature circuit breaker. What is electric shock? What are the precautions we should be taking when after the shock? And like what is earthing? There are two types of earthing are there, pipe earthing and plate earthing. This is all for the protection. So the earthing and protective devices, they are meant for the protection of the equipments and the protection of the human beings. In the module 4, we are going to learn about the DC generator and DC motor. In case of machines, we are going to study about the operation, construction, and if there is a EMF voltage or a torque related things, those things we are going to talk about. In module 5, single phase, three phase synchronous generator, again same operation, construction, and some aspects of that particular machine. Then EMF equation in case of a three phase synchronous generator or AC generator. Similarly, this is the AC motor, three-phase induction motor. We will study principle of operation, generation of a rotating magnetic field, construction and working of three-phase induction motor, slip and significance, necessity for starter, star delta starter. These are the things. The module 4 and 5, you can see module 4 is a DC generator and motor, module 5 is a AC generator and a motor, and module 3 is a transformer and domestic wiring. So these are the same machines you are going to study, and these are the prescribed books. Okay, the textbook you can refer is Basic Electrical Engineering, DC Kulashrestha, and I would be, most of the time I would be referring to the second one, Principle of Electrical Engineering and Electronics, VK Mehta. VK Mehta book is there for basic electrical principles of electrical engineering. Another book is Electrical Machines by VK Mehta. So all the machines are done from the Electrical Machines VK Mehta, and basic electrical is from this particular book. And for that matter, you can refer to any books, and also you can refer to the notes, and that is how you can prepare yourself. Okay, that completes the introduction. Okay, so you know the prescribed book, and what is the complete syllabus. From next session, we are going to start with the module 1.